previous session we have discussed about the Bernoulli equation. Okay, the total energy remains constant, and pressure plus velocity or the kinetic energy plus the potential energy. These three together always remains constant. Okay, so there are many real world phenomenons which can be explained using Bernoulli's principle. So we have discussed about the in aerospace engineering how the lift is getting generated to balance the weight. Okay, so how that generation of lift, how it can be explained using Bernoulli's principle. Okay, then there are uh, some other phenomenon which can be explained using Bernoulli's principle. One of them is your heart attack. Okay, heart attack. So, uh, so basically, what is your heart? It is nothing but a pump. Okay, so pump is something which supplies pressurized fluid. Okay, either like say water or any other liquid, oil or whatever. Okay, so this pump is a device. Pump is a device which increases the which supplies pressurized fluid. Okay, so in our house we have a pump. Okay, so that pump is driven by a motor. So pump is coupled to the motor, and that pump is basically a centrifugal pump which creates pressurized water or whatever, so that if it is pressurized, it can go up. Okay, so suppose you want to send the water to a higher height. Okay, so you need to pressurize it, then only it can travel up. Okay, otherwise it's naturally it will go down. So if you want to work against the nature, then you have to pressurize it so that it can go up. Okay, so basically your heart is a pump. So your heart supplies like say uh, pressurized blood to different parts of your body. Okay, so uh, uh, so uh, these are called like say through arteries. Okay, uh, you have veins and you have arteries, let us say. Okay, so we know in general like in the veins the impure blood flows through the veins, whereas pure blood flows through the arteries. Okay, so pure blood is nothing but your oxygenated blood. Okay, so for example, in your lungs, which takes the oxygen, right? It throws out the carbon dioxide. So that oxygen mixes with your blood, and that oxygenated blood is being pumped to different parts of your body using the using heart, which is being a pump. Okay, so uh, the arteries and vein, the function is just reverse in case of right in case of heart, arteries and vein. Okay, just the
Veins
reverse.
carries
One is
oxygenated,
pure,
artery
pure
carries
impure, and
deoxygenated.
here it is impure pure kind of. Okay, so without not going to the details of it, so what actually happens? So let us say this is one of my artery, say heart artery. Okay, so when we consume foods having lot of cholesterol. Okay, cholesterol or oily food or too much of ghee and all that, when we take, then there are chances that if this is kind of a, you imagine that this is a pipe. Okay, through which pressurized blood is flowing. Okay, so so pressurized blood is flowing like this. So because of this deposition of fat, so the fat will get, let us say the fat gets deposited here. So let us say it will create a constriction like this. Okay, so the fat gets deposited and it creates some constrictions like this. Okay. So that's why they say that when they do angiogram and all, so they say that okay, there are few arteries with 50% blockage, with 80% blockage and all that. So what do you mean by that blockage? So let us say this is my diameter of the nominal diameter, and if there is blockage, then this will be, if this is D1, this is kind of D2, right? So this D2 by D1, right? If it is 0.8, that means there is 80% blockage,
Yeah.
right? So, sorry, D1
By
minus
D.
D2, D1 minus D2 by D1, if it is 0.8, then that is the blocked portion, because
Okay.
this is D2.
Delta
So,
D by
yeah, so this part is your D1 minus D2, right?
Yeah.
That is the blockage part.
Yeah.
So this is what you understand by blockage. So why blockage happens? Because of deposition of fats, which comes from foods containing a lot of oily foods and cholesterols and all that. Okay, so by equation of continuity, what you know, like say A1 V1 is equal to A2 V2. A1 V1 is equal to A2 V2. Right? So A1 you can write it as pi by 4 D1 square, right? Say capital D1 square.
Yeah.
Capital D1 square, and then V1 is equal to pi by 4 capital D2 square into V2, right? So this pi by 4 you can just forget, pi by 4 whatever. So you can see here, if area is high, so you imagine this 2 is at this constricted location.
V.
This is 2, okay? So at 2, your A2 is less,
Yeah.
right? A2 is less. So your
A-
cross-sectional
the
area
area
is
is
coming
less.
down. That means your V2 will be high. So your velocity has gone up there, okay? So when this velocity goes up there, according to Bernoulli's principle, P plus half rho v square, forget h now, okay? Half rho v square plus rho gh or whatever, right?
Yeah.
This is your equation. So A is equal to constant, right? So just ignore this part now. So P plus half rho v square is equal to constant. Okay. So from this you can interpret that because the velocity has increased here, that's why the P2, that implies your P2 has decreased. Okay. So that means so the internal pressure. So inside the artery, the internal pressure at cross section 2 at point 2 has decreased. Okay. That means the internal pressure has decreased. Okay. So if the inside pressure has decreased, anyway outside this artery there is one external pressure also acting. Okay. So if the inside the pressure is decreased, outside force will try to further collapse this artery.
Make it more.
Okay. So it will try to collapse this artery, and it will kind of almost close this artery. Okay. So when this artery gets closed, there will be more pressure on your heart. Okay. So your heart will be under severe pressure to push through blood there. Okay. So the more it will try to push through blood, the more will be the increase in velocity there. It is kind of a cyclic process. Like it will get aggravated further and further. So the more is the pressure on your heart to pump the blood, it will try to push through blood through this. Okay. So it is so constricted now. So the velocity will be still higher there.
Yeah.
If the velocity is high, there further decrease in pressure, and in turn it will completely close the passage, and then it will lead to heart attack. There won't be any further supply of blood to other parts of your body. So the when we supply oxygenated blood to different parts of your body, that oxygen reacts with your carbohydrate and other food, and then you get energy out of this.
Yeah.
You know, the carbohydrate plus oxygen, it gives you energy, and your body function, all your regular activity takes place, right? So when you are not able to supply blood, that means your heart is not able to supply blood to different part of your body. Oxygen is not going to different parts of your body. That is causing the heart attack. Okay. So with the help of Bernoulli principle, we are able to explain the phenomena of heart attack. And that's why they say that don't consume too much of oily food containing too much of cholesterol, because that will lead to deposits on your arteries, and that will cause heart attack. Okay, clear?
Yeah.
So you take a picture of this. So one more interesting phenomena, the real world phenomena, which is so uh, so this is kind of the heart. If you see na, so let us say this is my heart, okay, which is kind of a pump, okay, and this pump, the because of this, to the different parts of the body, the blood is being supplied. Okay, so next is your in cricket. Okay, in cricket, the spin bowling. Okay, spin bowling, how we apply the Bernoulli's principle in spin bowling. Okay, so that is otherwise called as uh, 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 the that is called Magnus effect. Okay, that phenomena is otherwise called as Magnus
Magnus
effect.
effect.
Magnus effect. Okay. So I'll give you two types, like when the ball is spinning, when the ball is not spinning. Okay. Suppose normally the spin bowler, he will any bowler, he will try to throw the ball. So it will, because of the gravity, it will follow a path of a projectile, right? So if you are throwing a ball, it will follow a path of the projectile, right? You follow the path of a projectile. So let us say my ball is here. Okay. So let us say this my ball is here. Okay. So okay. So when the ball is like this, uh, but this ball is not spinning now, right?
Yeah.
This ball is not spinning. When it is spinning, it will spin.
Yeah.
Okay, it is not spinning now. So the streamline around the ball. So it will be like this. There will be some streamlines around the ball, which will be symmetric in nature. Okay, so kind of okay. So these are kind of streamlines, okay? The flow line around the bulb, the fluid flow, the air flow. So this will be kind of okay. So the distribution of the streamline around the bulb is almost uniform. Okay, in this case. Okay. Uh, um, so this is without spin. Okay. So this case is ball without spin. Okay, without spin. Without spin. Okay. So now you imagine this ball. If you spin this ball, okay. So let us say this is my. So let us say this is my ball. Okay. So now you are spinning this ball. The spin bowler, what he does, he spins it like this.
Yeah.
He just not throw it like this. Along with that, he will spin it like this. When it spins, the ball is rotating around its own axis also, right?
Yeah.
When it is rotating around its own axis, you imagine that you have a layer here, and you have the air is flowing. Okay, so let us say your air is flowing. So when this air is flowing, because of this spinning action, this effective velocity here will increase. Okay, let us say this effective velocity here, another component of velocity will be there, whereas here it will be opposing that. Okay. Okay, so this is, put it like this, red is better. Okay, so sorry. No, this is black is better. So this is this and this is this. Okay.
Yeah.
So here, because it is rotating like this, right?
Yeah.
Like this. So here, so this is normal airflow velocity. Okay.
Yeah.
Airflow, main airflow velocity. This is the additional velocity because
That
of the
gets added
spinning
because
of the
of
ball. Okay. So this is spinning, because of spinning. Okay. So if the tangential velocity of the ball, let us say, this is let us say 100 meter per second. Okay. And the tangential velocity of this ball, the tangential velocity, let us say it is 10 meter per second. Okay. So on the top surface it will become 110 meter per second, right? Which is 100 plus 10
Yeah.
is equal to 110 meter per second. Whereas at the bottom, this spinning is opposing the motion of the flow of the
Ball.
fluid. No, air is flowing.
Air.
So this is air flow.
Yeah.
This is air flow. So this air flow, it is flowing at 100 meter per second. So
But
because
that
of
is
the spinning,
opposing
it will become 100 minus
Minus
10,
10.
which is equal to 90
90
meter
meter
per
per
second. So that means on the top,
It is
the velocity has
is more.
increased. On the bottom, the velocity has
is
decreased. Okay. So because of this, so let us say this is the top surface. Let us say the velocity at top. Let me write it as Vt, right? Vt.
Yeah.
Okay. Let me say this as
VB.
velocity at bottom, right?
VB.
This is my Vb. Okay. So you can see Vt is greater than Vb.
So pressure at T is
That
less
means
than
Pt,
is
pressure at top is less than pressure at bottom.
Like
Okay.
aircraft.
So the pressure at the top now decreased. Okay. Because it has decreased, it will not follow a projectile path. Instead, it will deviate from the projectile
You
path.
cannot predict the path
Ah.
of the ball.
So, because it will not, like this ball, once it starts spinning, it will not follow the projectile
It
path.
will deviate.
Instead, it will deviate. Okay, so instead it will deviate. So, if it deviates from its path, it will be very difficult. Like say you have the bowler here. Okay, say let us say you have the bowler. Okay, and then you have the batsman here. Okay, so you have the batsman. So if it is projectile path, he can easily
Pick the ball.
predict how the ball is going to come. But if it spins it, then he cannot. He will not be able to predict how the ball, where it is going to. So this ball not only it can spin in, it can it can deviate in upward downward direction. It can also deviate in left right also.
Okay.
So some spin bowler they can do it like this. Some bowler can do it like this also, like this or like this. And when you mix both the things, it will still be very unpredictable. Okay.
Understood.
So there was some event like this. Pakistani players were suspended for ball tampering. So what did it? So this is your ball. So some people what they do in ball tampering, they will remove some bit
Part
of
of the ball.
some bit of material from there. Okay. So if they remove by rubbing it, you might have seen that they are rubbing it on their pant. So by rubbing it, they are creating a rough surface. So by creating that or that creation of rough surface is called ball tampering. So if they create this kind of rough surface, the path of the path of the ball will be further unpredictable. Okay. So this type of deviation from the intended path by spinning the ball, this type of phenomena is called Magnus effect. Okay. And again, similarly, ball. So this is ball moving without spin. This is ball moving with spin. Okay. And this phenomena is called Magnus effect. And then there is the third one, that is the airfoil wing. Okay. So that will just put it. Okay. You take a picture of it. Okay, so now the third one is your aerofoil or lift on aircraft wing. That is, I have already explained, but okay, airfoil or lift on aircraft wing. Okay, we have already solved a numerical related to this. So your wing, if you like say. Let us say this is my kind of. So this is my aircraft, let us say, and let us say this is my wing. Okay. So if I take a cross section of this, okay. So if I take a cross section, it will be something like this. Okay. Okay. The wing will look something like this, and on the top surface, so these are the streamline of airflow. Okay. Okay. So on the top surface, so and in the, let us say, in the bottom surface it is something like this. Okay. So your this is your leading edge. Your aircraft is moving like this. Your aircraft is moving like this. Your flow lines are going like this. Flow lines are going like this. And you will see that on the top surface, they say that these flow lines are crowded. Okay, so the density of these flow lines on the top surface will be high, and the velocity will be high on the top surface. Okay, so it will be crowded,
Pressure
and
will be less.
the velocity will be high. Okay, so let us say this is Vt, this is Vb, right?
VT is
Velocity
greater
at
than
bottom.
VB.
Okay, so so this Vt
It's
will
greater.
be greater than Vb.
VB.
Okay, bottom.
VT is less than
That means P top is less than
because
P
of
bottom.
pressure difference.
That
it
means
will-
force at the top is less than force at bottom. So
You
Fv minus Ft is the net force, which is the lift acting
which
on it.
acts on it due to this pressure difference, it is lifted
Yes.
upwards.
So another way you can explain it is like this. Like say this is my, let us say I draw it like this. Let's say let me try to draw it something. Let us say I draw it in a horizontal manner. Okay. So the my aerofoil surface is looking something like this. So my air leaves point 1 and it reaches point 2. So you can see here aerofoil surface, the top surface is kind of a little bit more, it has more curvature as compared to the bottom one. So the distance covered, so if you measure the total distance on the top from point 1 to 2, let us say that distance, let us say that is 120 meter, let us say. And the bottom one will be little less, which is 100 meter. Okay. So you imagine that I am at 10th second, I am here at 11th second, it has reached the point 2. That means in 1 second, on the top it has covered 120 meter.
Below it is
In 1 second, the bottom has covered 100 meter. Because on the top you have to cover more distance. Okay. So because you have covered more distance, that's why your velocity at the top
will be
is high and velocity at the bottom is low.
low.
That means pressure is low at the top and pressure at the bottom
is high.
And which will give rise to
Pressure
the
difference
leak.
and leak.
Okay. So why this aerofoil shape is important? Nowadays you might have seen earlier days. Okay. So you can have a rectangular cross section also. Okay. So this rectangular cross section when it cuts the air, it will completely obstruct this air because of the sharp edges. Because of the sharp edges, it will completely obstruct the air and there won't be any lift generation. Okay. And this will give rise to very high drag and very high friction. So you might have seen this evolution of this automobile also. Not only in aircraft, but also in automobile you might have seen that body of the automobile. In Maruti 800 how it was and the modern day cars how it was. So these cars are very aerodynamic shape. So they don't have sudden change in cross section. So the earlier you might have seen the shape was like this, but now they want to make the shape something like this, so that there is much lesser drag as compared to this. So these were the earlier days automobile body, and modern days they want to make it aerodynamic shape so that the flow will be streamlined and there will be less and less drag. Okay. So I have explained you the application of Bernoulli's equation in the real world problems, like say causes of heart attack, and then Magnus effect, the spin bowling in cricket and in aircraft. So there are many applications of this Bernoulli's equation. I have just picked 3 out of it. Okay. Okay. Thank you.